Good morning. We are here today to learn about the fascinating world of acids and bases. We will explore their properties, chemical formulae, pH levels, and how they interact with other substances. Let's get started. Acids are compounds with a high reactivity that form hydrogen ions in water. They can be distinguished by their sour taste, and their formulas generally start with a H. Acidic substances are poisonous and can cause burns on the skin, so it is necessary to take necessary precautions when handling them. An acid usually has a pH lower than 7. Alkalis are an integral part of chemistry, releasing hydroxide or O ions into water. They have a bitter taste and a slippery feel, and are capable of breaking down fats and oils. Generally they will have a chemical formula ending with O. However, alkalis can be highly poisonous and corrosive to skin, with a pH greater than 7. Bases are a key chemical, employed in many ways. They can make red litmus paper blue, and when heated alongside ammonium salts, they emit ammonia gas. Furthermore, in a solution including one metal salt, they can yield another metal salt and metal hydroxide, helping us identify the characteristics of acids and bases and how to safely use them. The pH scale is a measure of acidity or alkalinity in a substance. Acids have a pH of less than 7, and alkalis have a pH of more than 7. It is crucial to understand pH to comprehend the characteristics of acids and bases. Acids and bases are important components in chemistry. The Arrhenius theory serves as a useful tool to explain their properties. As per this theory, an acid is a compound that releases hydrogen ions in water, and a base can accept hydrogen ions. This explains the sourness of acids and the bitterness of bases. Acids can also react with other compounds to create specific products, while bases can neutralize acids. Comprehending the Arrhenius theory enables us to recognize and explain the characteristics of acids and bases and their reaction with other compounds. The Arrhenius concept of acids and bases is highly significant in chemistry. It states that an acid is any substance that increases the concentration of hydronium ions, H3O+, when dissolved in water. It does not matter what its chemical formulae, pH level, or other features are. Additionally, it is important to bear in mind that aqueous hydrogen ions are bound to water, namely H3O+. Mastering this idea is critical to making use of the varied properties of acids and bases correctly. The Arrhenius concept is a widely adopted theory for elucidating acids and bases. It states that acids are compounds that, when dissolved in water, increase the concentration of hydrogen ions, H+, Aq, whereas bases enhance the concentration of hydroxide ions, O, Aq. This concept aids in explaining the reactivity of different substances with each other, such as a strong acid is more likely to react with a strong base than a weak one. The Bronsted-Lowry definition of acids and bases in chemistry states that an acid is a compound capable of donating a proton, and a base is a compound capable of accepting a proton. For this to occur, both need to possess a non-bonding pair of electrons that is available to form a bond with a proton. When an acid donates a proton, its conjugate base is the species created after it donates the proton. HCl donates a proton to form its conjugate base H3O+, and the product of the reaction, H2O, is the conjugate base of the HCl, capable of accepting a proton. Cl ion, created in the reaction, is the conjugate base of the original acid, HCl, which is capable of accepting a proton and restoring the original acid. This exemplifies the fundamental concept of conjugate acid-base relationship in chemistry. Water is capable of behaving as both an acid and a base due to its amphiprotic nature. Its pH level may differ based on the substances it interacts with. As a general rule, strong acids have weak conjugate bases and weak acids have strong conjugate bases. A prime example of this is ethanol. Its acid form, C2H5OH, is weak, yet the conjugate base, or ethoxide ion, C2H5O, is strong. Lewis acids and bases are chemical compounds that interact leading to covalent bond formation. Bases donate a pair of electrons while acids accept, resulting in the bond. In contrast to traditional acids, many Lewis acids don't contain hydrogen. Acids and bases have a multitude of important properties with regards to their use in chemistry. These include their acidic or basic nature, chemical formulae, pH levels, as well as their reactivity with other compounds. Being aware of and understanding these characteristics will aid in guaranteeing that these substances are employed in a safe and effective manner. Acids and bases possess properties that are utilized in practical applications. Generally, when an acid and base react together, they will undergo a neutralization reaction, which results in the production of a salt and water. For instance, when acetic acid combines with sodium hydroxide, sodium acetate and water are produced. In a similar way, when sulfuric acid and, say, copper oxide interact, the result is copper sulfate and water. Additionally, acids are able to react with ammonia producing a salt. An example of this is the formation of ammonium chloride. Knowledge of the properties of acids and bases is beneficial in comprehending chemical reactions and creating industrial and consumer products. Hydrochloric acid reacts with reactive metals to form salt and hydrogen. For example, 2 moles of hydrochloric acid reacting with 1 mole of magnesium produces 1 mole of magnesium chloride and 1 mole of hydrogen gas. Likewise, when 2 moles of hydrochloric acid reacts with 1 mole of calcium carbonate, it produces 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of water. Additionally, when 1 mole of hydrochloric acid reacts with 1 mole of sodium hydrogen carbonate, it produces 1 mole of sodium chloride, 1 mole of carbon dioxide, and 1 mole of water. Compounds classified as strong acids and bases are those which completely dissociate into their respective ions when dissolved in aqueous solutions. Hydrochloric acid, nitric acid, and sulfuric acid are among the most commonly encountered strong acids. In water, these compounds release hydrogen ions, leading to a strong solution of high acidity. Strong acids and bases have greater resistance to pH changes. Sodium hydroxide, potassium hydroxide, and barium hydroxide are all strong bases with high reactivity. These bases can neutralize any acidic substances they interact with, making them important for many scientific processes. Weak acids and bases are compounds that slightly dissociate into their ions when added to an aqueous solution. Ethanoic acid, CH3COOH, and carbonic acid, H2CO3, are examples of these acids. Compared to their stronger counterparts, weak acids and bases are less reactive, and thus less corrosive and safer to use. Weak bases like ammonia and aminoethane have a basic pH and exhibit relatively low reactivity compared to other bases. The chemical formula for ammonia is NH3, while aminoethane is C2H5NH2. These types of bases typically have a lower pH level than other bases. Acidic oxides are a group of nonmetallic compounds which, upon mixing with water, generate acids. Examples of acidic oxides are sulfur dioxide, sulfurous anhydride, sulfur trioxide, and sulfuric anhydride. Such substances display acidic properties and can be distinguished by their chemical formulae, pH levels, and reaction to other materials. Basic oxides are substances created by combining a metal and an oxygen molecule, with the ability to influence the acidity or basicity of a substance. These oxides are soluble in water, and when they interact with it, they form a hydroxide or an alkali. Conversely, basic oxides do not interact with alkalis. Examples of basic oxides include calcium oxide, magnesium oxide, calcium hydroxide and magnesium hydroxide. Amphoteric oxides are unique in that they can possess both basic and acidic properties depending on the type of reaction they come into contact with. When reacting with acids, these oxides will produce salt and water, a result that indicates a basic property. When they come into contact with alkalis, they will once again produce salt and water, which is indicative of an acidic property. This duality of characteristics makes amphoteric oxides a valuable resource in chemical reactions. Neutral oxides have neither basic nor acidic properties. Examples of this include carbon monoxide, nitrous oxide, and nitric oxide. When reacting with acids or bases, they do not form salts, making it important to be mindful when handling them.